I'm just getting this formal definition down so you have it, and you can put it right on your template. So as I understand it, you guys have been getting a lot of these types of templates and note sheets. They're for your information to study from, to help guide you on unfamiliar information. All right, this is covering the last two sections of chapter 3. I believe, does it say on the top of your sheets that this covers sections 3.8 and 3.9? Okay.
Yes.
So you have a reference point in terms of sections covered. Okay? So let's look carefully at this definition, and then we're going to go into something called a mapping diagram. So a mathematical function can be defined in a few different ways, but the way we're going to formally define it for us is a correspondence between two sets, D and R, that assigns each member of D exactly one member of R. Now these letters D and R actually do mean something. Does anyone know what D and R actually stand for, or have heard words, one of which begins with a D and one of which begins with an R? DR stands for doctor, right? Yeah.
Diameter and radius.
Okay, diameter and radius are two awesome math words that have to do with circles, but functions call for two other words that begin with a D and an R. Maybe I can give you a clue in that you know you're going to be dealing with an X and a Y. Okay? And mathematicians came up with vocabulary to understand the input and the output of a function. So just so you have it, you can add this to the side of your note sheet. The D stands for the word domain. Okay? Domain or X values of a function. This is what's going into the machine, into the function. What comes out is your range. All right? Every member of D must be assigned to exactly one member of R. So here we go with your first look at a mapping diagram. I'm just going to throw down 3 numbers into my domain portion of the map. Remember guys, domain stands for your input or your X values, okay? Let's put in 3 numbers into our Y map, 7, 6, 4. Okay, functions map or place one number onto another. So what I'll show you is this, that -3, for example, could be mapped to 6. 2, for example, could be mapped along to 7, and 5 to 4. Does every member of D have exactly one member of R? Okay, this makes it a function. Okay, so in the question part, yes. Okay? So to show you kind of what would make something not a function, I'm going to go over here. Same numbers, but a different map. Same numbers in the D or input mapping portion. Same numbers into the range. But I'm going to just map them out a little differently. And watch right here, very important, what makes something not a function. I'm going to map -3 to 6 again, but I'm also going to put it to the 7. Okay? Once you assign that domain value more than one range value, this is the big no-no. Okay? So what you guys really need to remember is what makes something a function and what makes something not a function. From there, if I was to say, all right, that goes to the 6, that goes to the 4, I'd be okay. But this matter right here of assigning that input value more than one output value, I'm in trouble. Okay? By the way, these input and output values are the same exact thing as what you guys learned in graphing. By the way, -3 to 6 is just a coordinate pair. It's the same idea. Input, output. functions are just a fancy way to kind of call this out. Negative 3, 6. What would this coordinate be, Erin? 2, 7. Swabi? 5, 4. Okay, these values would be a part of your function. Okay? This one, which does not represent a function because negative 3 shared 7, but it also had 6. So this repeated x also tells you that it's not a function, okay? You had 5, 4, and 2, 6, but right here, repeated x, not a function. Okay? So what you guys are actually going to see right now is what's called function notation. And the example below shows just that. So here's an example of what you're going to see, assuming that it is a function, that every member of D has exactly one member of R. We're going to model this function right here. This is called f of x. There's a little lingo there. F of x equals 2x minus 1. Okay, guess what? F of x equals 2x minus 1 is the same exact thing that you guys probably know and have understood to be y equals 2x minus 1. It's the same idea. So this fancy notation, function notation, honestly just means another way to write y. Okay? So don't let that throw you off when you're doing the math. Watch up here at number 1. Take function f and put what into it? What is it saying to put in? Negative 1. They want you to put this into your machine. So watch what we're going to do. F of negative 1 is going to equal. Put it through the machine. 2 times negative 1 minus 1. 2 times negative 1 minus 1. It's just another way to note y equals 2x minus 1, f of x equals 2x minus 1. So we do the math, and we get f of negative 1 equals negative 3. Input, negative 1. Output, negative 3. Input, negative 1, output, negative 3. So if I was to do a mapping diagram, where would I put the negative 1? In the first part or the second? First part, so I put a negative 1 in there, mapped with negative 3, right? Now the second one, don't put in a number, put in a letter. Take machine G, put in A. Take machine G, put in the letter A. Kind of weird, but you can do it, right? It's just like putting in a number. So G of A equals A squared plus 1. Unfortunately, you don't know what A is. Can't solve it. You're done. So the first one had a nice numeric answer, fine. But sometimes you put in those inputs and it's just an abstract expression. Okay? Now, on to these last two. They look kind of crazy, right? Pull them apart. Here's your hint. Start from the inside if you want to make that note. Start from the inside, work out. Okay, again, this is just a quick tutorial. You're going to get more practice with these within your packet. So watch what I mean. Start inside. Delete the G for a second. What does it say to do inside? F of 2. So let's put 2 into machine F. So F of 2, I'm just going to leave the G on the outside for the moment. 2 times 2 is 4 minus 1 is. So I started from the inside, I got 3. Now, take 3 and put it into machine G. So you take it in stages. F of 2, done. We got 3. Now take 3 and put it where? In for X in what machine? G. 3 squared is 9 plus 1 is 10. Take a minute right now, see if you guys can try this one. Take G of negative 1 and try and put it into F afterwards. So start from the inside, work out. take g of -1, get a number,